look, I think just to take a step back and look at the evolution of this, 5, 10 years ago, the same problem has existed back then, except the stakes were much, much lower, right? I think, call it 10 years ago, there were just a handful of people in an organization looking at data. You had a lot of time to make sure the data is accurate. Fast forward to today, most everyone in an organization uses data and AI as well, increasingly. And so in that world, it's really hard to let any data issues slip. And I'll talk about the implications of what bad data looks like for the data team, for the business. When you think about the implications for the business when it's external product, it's a way bigger deal. Just a couple of examples that, come to mind. I think this was like early 20s when Unity, which is a gaming company, had one schema change that cost them $100 million. Stock dropped by 37% the day after. It was a big deal. One schema join. I think this was 4 or 5 years ago. More recent, a few years ago, Citibank got hit with $400 million for fine for their data quality practices. So now you're talking about pretty significant revenue implications and regulatory fines and risks that organizations are really held to.
If you're building with AI, but your data feels duct taped together, you're not alone. In this episode, I have the great pleasure of speaking with Barr Moses, CEO and co-founder of Monte Carlo, about the growing gap between the pressure to build with AI and the reality of unprepared data infrastructure. We cover why your moat isn't the model, it's your data, and why most organizations aren't protecting it. Why so few companies are actually AI ready today, and why that gap is more alarming than it looks. We also discuss a new playbook for observability, tracing failures across data, code, systems, and model output. How multi-agent LLMs are already reshaping data debugging and where this might lead next, as well as why most teams are still managing data like it's 2015, while trying to ship generative AI products. Barr brings battle-tested stories, practical frameworks, and a clear-eyed vision of where the data and AI stack is headed next. If you enjoy these conversations, please leave us a review, give us 5 stars, subscribe to the newsletter, and share it with your friends and colleagues. Links are in the show notes. But before we jump in, let's just check in with Duncan from Delphina, who makes high signal possible. Duncan, I'd love to hear just a bit about what's up at Delphina and why you produce high signal.
At Delphina, we're building AI agents for data science. And by nature of our work, we get to meet with lots of leaders in the field. And so with the podcast, we're trying to share the high signal.
So cool. And speaking of leaders in the field, and speaking of data science and agents, in this episode with Barr, we had a wide-ranging conversation, particularly about the importance of data and observability and monitoring in our practice, which you can forget about sometimes. So I wonder what resonated with you, particularly from the clip we just showed.
Barr famously coined the term data downtime. And I think that if you've ever shipped a model or owned a dashboard or been ambushed by a "why is this number wrong" Slack message, you know how real that is. When I was a data science director at Uber, I was paranoid to the point of nausea about bad data. I'd walk into these 100-person tech reviews with our CEO, Dara, knowing that getting one metric wrong in that deck could incinerate trust and send large organizations in the wrong direction. And frankly, as a data leader, it could even cost you your job. And Barr tells the story of a single schema change that cost a company $100 million. And that's not even the wildest example. This episode is way more than war stories. It's a crash course in what it takes to earn and keep that trust in your data. And I think that if you've ever felt a knot in your stomach about whether data is right, this episode really hits home.
Without a doubt. And I really appreciate you bringing your expertise and experience from Uber into the conversation as well. So without further ado, let's jump into the conversation with Barr. Hey there, Barr, and welcome to the show.
Hey, great. Thanks for having me.
Such a pleasure. So, co-founder and CEO of Monte Carlo.
That's right. Having fun doing it.
Having fun doing data quality stuff, observability stuff. As you know, I have strong feelings about the model-centric world that we live in. Not enough public conversations, particularly on, LinkedIn, or as I like to call it, TikTok for adults, about data quality and observability. As people on the ground know that data is primary, right? AI adoption's moving fast. Many data leaders feel their data isn't AI ready. From all the people and companies you speak with and work with, what are the biggest challenges that companies face in making their data actually useful for AI applications?
Yeah, great question. And look, I think maybe just to kind of take a step back and sort of look at the evolution of this. 5, 10 years ago, the same problem has existed back then, except the stakes were much, much lower, right? So, I think call it 10 years ago, there were just a handful of people in an organization looking at data. You had a lot of time to make sure the data is accurate. Fast forward to today, most everyone in an organization uses data and AI as well, increasingly. And so in that world, it's really, really hard to let any data issues slip. And so, I'll sort of talk about the implications of what bad data looks like for the data team, for the business. And so starting with the data team, it's very common for data engineers, AI engineers, data analysts to be sort of hit with complaints from folks downstream asking, why the hell is the data wrong? Or what the hell is happening here, right? And sometimes it can be internally focused, which is not a big deal, maybe. Like, for example, if you have an internal user who's sort of, asking why something is wrong, or, highlighting an internal chat bot that gave a wrong response, maybe that's okay. Maybe you can get away with it. When you think about the implications for the business when it's external product, it's a way bigger deal. So just a couple of examples that, come to mind from, recent, I think this was like early 20s, when Unity, which is a gaming company, had one schema change that cost them $100 million. Stock dropped by 37% the day after. It was a big deal. One schema join, That's like, I think this is like 4 or 5 years ago. More recent, a few years ago, Citibank got hit with $400 million for a fine for their data quality practices. So now you're talking about pretty significant revenue implications and regulatory fines and risks that organizations are, really held to. Taking that forward to today's world, just sharing a couple of more recent examples. My favorite example is actually this kind of went viral on X. Someone Googled, what should I do if cheese is slipping off my pizza? And Google responded, well, you should just use organic super glue. And, okay, haha, funny, right? Like, we all find it ridiculous. How many companies in the world can get away with that? Yeah. Like, sure, maybe Google can get away with it, and I'll still be Googling tomorrow. But most enterprises can't get away with that level of mistakes. And, just as an example, I think there's, a car company, Chevy Tahoe, that a user basically convinced their agent to sell them a car for $1. Yeah. Like, I commend the user who was able to do that, right? Like, awesome use of AI, if you will. What are the implications of that on that organization's reputation and brand and revenue? And so, I think the types of issues that organizations have as a result of bad data in AI start from revenue, brand, reputation, and all the way to, data engineers just like waking up in the middle of the night worried about receiving an alert or hearing from a downstream consumer about something that's wrong. That's really sort of at a high level, if you will.
Yeah, I appreciate that. And I really love the examples that you grounded it in. I do want to ground it even further. And I'll link to this in the show notes. But at Monte Carlo, you have a wonderful recent survey that showed 100% of data leaders, 100% of data leaders feel pressure to build with AI, right? But only around 60% think their data is AI ready. So why does this gap exist? And how can organizations go about bridging it?
Yeah, it's such a great question. And I love this survey because, when we did the survey initially, I was like, okay, probably like, maybe 80% of people would say that they're sort of, doing something with AI. But literally, like, there wasn't a single person on the survey who was willing to admit that they're not doing something with AI, right? Like, that's how big the pressure is. Another anecdote from the survey, I think also 90% of respondents mentioned they do have AI in production. So I think it's, there's a certain, obviously there's hype, but we're also moving to a place where people actually have AI products in production, and they are looking to tie that to real revenue and real ROI. However, I think, the point that you pointed out and where the friction is that only 1 out of 3 actually think their data is ready for AI. And that's really troubling. Why is that troubling? This is something that you and I talked, before the podcast. I think historically in the last couple of years, there's a lot of discussion about the latest and greatest model, right? And you can discuss whether it's like open source or closed source and, OpenAI, Anthropic, Meta, a lot of different contestants out there. Obviously, DeepSeek Monday was a big deal, right? For folks who don't know, DeepSeek sort of showed the ability to create a much better model at a much lower cost, right? And so there's a lot of drama around that. I think the hard truth or the hard reality is that today, anyone has access to the latest and greatest model. And so within a couple of seconds, maybe a couple of minutes, we can all get an API key and off we go. And so in that world, what is our moat, right? As organizations, what is our competitive advantage if everyone has access to the latest and greatest model? And what we are seeing and hearing time and again from enterprises is that your moat is your data. And why is that the case? Actually, the chief data officer of JP Morgan Chase was interviewed a couple weeks ago to the Wall Street Journal, and she had a really nice quote which says, the model, and I'm paraphrasing her a little bit, but she said, the model is not our secret sauce. Our secret sauce is the information that we use. What does she mean by that, right? On the one hand, internally, we can use information that we have to basically automate the processes that we have. And externally, if I'm building a financial advisor or some concierge, if you will, my ability to make that product much better for, say, Hugo would be based on the information that I already know about you or other data that I have about your preferences. And so my ability to make this product way more powerful is based on that data that I would have about you. And so, AI ready data is a really big deal for organizations today. And I think the gap there is that, in my opinion, we are thinking about data and AI management in the wrong way. And what do I mean by that? I think the data and AI estate has changed significantly in the last 5 to 10 years. Like, you can't even compare the way in which we manage, transform, process data and AI compared to where we were 5, 10 years ago. However, absurdly, we still manage the data and AI estate in the same way. So I'll give you an example. I was just speaking to an AI leader in a Fortune 500 company, a company you've all heard of. I was basically talking to them about how are they evaluating the reliability and the quality of their AI products. And, he was basically telling me, we basically have like a human being, a user, kind of go through and sift through 200 responses and sort of evaluate them, like 200 responses a day. And that's a grueling process for a product that's supposed to be highly automated and highly reliable, right? And it sort of reminds me of back in the day, like 5, 7 years ago. And, I would ask chief data officers, how are you making sure your BI solutions are reliable? How are you making sure your reports are accurate? And they would always tell me, I have 8 pairs of eyes look at reports every morning to make sure the data is accurate. So in a sense, like, we're still using the same methods for management of the quality of our data and AI, and we haven't adapted. And I think that gap that you called out is a direct result of that. We need to evolve, and we need to improve how we do our data and AI estate management in order to catch up with all this innovation that's happening.
And what do you think, like, the top couple of things people can do practically in their organizations to improve their data estate management?
Yeah. Look, I wish this was magic wand and like easy to do and just, completely done. I think there are a couple of things that are obvious and maybe a couple of things that are not obvious. I think the obvious thing is make it a priority, right? Like, this should be something that's a top level company priority, and many organizations are doing it and saying, what percentage of our data is AI ready? Can we create a data trust score? How can we measure this? What's the percentage of data incidents that we have? What are the SLAs that we have? Just in the same way that you have like 5 nines of availability for your application, you should have some nines for your data, right? For your data and AI, downtime and quality. And so I think starting by making this a priority, and we see this more and more, a Fortune 500 bank that I'm sure you've heard of, and I hear that their CEO on a regular basis looks at reports and sends angry emails asking why the data is wrong. And after too many of those reports, he just decided to make it a company-wide initiative to make sure that the data that all of his executives and staff are looking at should be accurate. So I think it takes, again, this is obvious, but it takes a decision to say this matters. And if we want to be best in class in AI, it starts with best in class data. Like, your AI is only as good as your data. So that's maybe one thing that I'll call out as obvious, but needs to be done. Now, let me call out something that I think is less obvious, but I feel strongly about, is what I've learned from doing this thousands of times now with enterprises. I think we have to, historically, we've really thought about data quality as a point in time thing, and really has to do with like detection of incidents. And so, people would typically write, SQL queries or have some other manual ways, some checks, whatnot, to make sure that the data is accurate. Right. And then, the data team is inundated with alerts about things wrong. And that's about it. But like, we have data quality, so we're good. Right. I think that doesn't cut it. I think doing detection is very important. And you can actually do detection of data issues better with AI today. Happy to talk about that separately. But I think you have to have world-class ML and AI-based detection. But I actually think the non-obvious thing to think about is, how do you do really strong troubleshooting and triaging of issues? And what we found is that data and AI issues as a whole can be trace back to 4 core reasons for why data and AI goes wrong. The first is you can have pure bad data. Like literally, you could be ingesting bad data. Like let's say I'm an airline and I'm ingesting data about where's your luggage or what's your next flight, etc. If that data that's passed on to me is like half null, in terms of like just receiving null values, that can actually cause a problem in, calculating the arrival time of passengers and making sure that, transfers happen on time, etc. So, the first thing that can go wrong is your data can go wrong. The second thing that can happen is you can have a code change that actually influences the reliability of your data and AI application. Now, what do I mean by code or code change? We write, or data teams write code to transform the data, to move it, maybe to like merge a couple data sets, like, the list of passengers and where their luggage is, for example. Or it might be code that goes into actually building an agent. In any of those instances, a code change can actually completely, undermine the reliability of your data or AI app. That's the second. The third core issue or root cause could be a system that goes down. Now, when I say a system, that could be a system issue. When I say system, I basically mean like all the infrastructure and sort of all the infrastructure that runs all these jobs. A practical example could be an Airflow job that fails, an issue with a dbt job. It could even be a transformation in Snowflake that you're doing. The thing is, systems are prone to fail. Like it doesn't matter. 100% of systems fail at some point. Those can lead to issues in your data and AI application. And the fourth thing that can happen, I think that's, where we're going as an industry, is you can have the perfect prompt and the perfect context, and still your model response will be not fit for purpose. And I think the Google example that I gave earlier with, use organic super glue to glue your cheese back to your pizza is exactly exactly an example of that, right? Or any sort of hallucination would be an example of that. And so even if everything is perfect, you still need a way to make sure that the output and the responses of the output of your model are still fit for purpose. And so I think, the non-obvious thing here is if you want to make sure that your data is AI ready and that your data and AI state is properly managed, you actually need visibility into your data, your systems, your code, and your model output. You cannot look at one, and I think the common mistake is to look at one versus the other, or to look at one at silo. It's actually the combination of all of those that gives you really, really powerful visibility. And the reality is that most data issues is actually a combination of one or more of these at the same time. And that's typically when, the data and AI team is sort of like, there's a fire drill and you have to figure out what's happening, and there's a war room. People are like, what the hell is happening? And then it's very hard to kind of unwind these things. But if you have proper visibility to all 4 of these, you can start actually moving from being in a very reactive place to a more proactive place.
I love it so much. And one thing you've spoken to there, I think, and we'll get to this later in the conversation, is the extreme importance of observability, because I think too many people think of data at the start of the pipeline and observability at the end, and not the holistic integration. And in the end, with data-powered products and data-powered software, we are essentially dealing with far more complex systems than traditional software, which traditional software kind of is the sum of its parts, but data-powered systems aren't in a lot of ways. And we're introducing essentially the entropy of the real world into these systems, right? And need to monitor them accordingly. A few other things you spoke to in there, which I find so interesting, and I hope we get there as well, is not only using data to power AI products, but how we can use machine learning and AI to inform us about data will be essential. And then you made me kind of remember, it was a post, a Hacker Noon post by Monica Rigardi, maybe, I don't know, like 8 years ago or something, called the AI Hierarchy of Needs, right? Which had, she's like, everyone wants AI, but and this is before generative AI, but let's look at what we need first. We need to log things, right? And then do basic ETL. And then only then can we start counting. And after that, if we have an experimentation framework, perhaps we can do experimentation, and then we can introduce machine learning. So it really is back to basics. And it's so important. And I think a point you made wonderfully there is it's not necessarily being AI first, it's being data first, and then figuring out how your data powers a variety of things, AI, ML, statistical inference, and otherwise. Of course, we don't then get like the cosplay and LARPing of, we're a Gen I native company and all of that, but we get to deliver real value. So this really brings me to the next question, I think. Like, data quality and observability are often treated as separate concerns. So how do they relate, and where should teams focus their effort?
Great question. And I'll talk a lot about the things that you said as well. I think you talked about various teams and how this compares to software engineering and software applications. I think the interesting thing about data products is that they are very many different and disparate teams are involved in building them. And so it's not uncommon to have an engineering team, a data engineering, an ML engineering, a data analyst, all contributing to a data product that you have a user consume at the end. And so actually each of these teams have are almost basically totally different personas. They're motivated by different things. They have very different skill sets, ranging from coding 100% of the time to point and click UI. They have very different understanding of data. So some teams upstream don't, honestly can't speak to, they might be responsible for storing the data, but they can't speak to how the data is used and why. And vice versa, you might have teams that are way closer downstream to the end user, but don't know what is the source of the data or where it's coming from. And so you're actually, it reminds me of that like meme with like the Superman, like three different Supermans pointing at each other. Like that's what that looks like when you build a data product. And so there's all these like people pointing at each other. Why am I sharing all of this is because I think there's a lot that data organizations can learn from software engineering. And so I think when I think about the difference between data quality and data observability, in my mind, data observability is taking data quality, which has been around for a long time, and taking that to the next level. I think I mentioned this before, like data quality really has sort of traditional tactics like testing and monitoring, which is really important. Like it's actually really critical to set up those, like unit test in the same way that you have unit tests. It's critical. And I don't think that's ever going away. I think data observability helps you take that to the next level and start asking questions like, what else do I know about my estate that can help me solve this problem? So, okay, I understand that there's a problem here, but there's a very high percentage of values that, in particular field typically have only, let's say it's a credit card field, and only 1% of the time, the value there is null. Suddenly the percentage of null values are way higher. It's like 40%. Let me start thinking about what's related to this. Was there a pull request at the same time that happened that I can actually, correlate to this? Was there a code change somewhere? Can I actually use AI to compare, what something that analysts do is like they actually sift through SQL code, like literally hundreds of lines of SQL code to understand what the problem is. Can I use the AI to start understanding like where was there a code change that could have contributed to this? And, sort of taking that to the next level really draws on experience from software engineering that has been using software, observability for the last couple of decades. I do think the next evolution is data and AI observability. And I think there it's a lot more visionary because people are not building so much with AI yet. But when they are building, with AI, the reliability and the output and the quality of those products matter a lot. Does that answer your question?
It definitely does. And I totally agree that, from software engineering import several things. I do think there are slight shifts in terminology, which I find really fascinating. So I work with a bunch of people helping build AI-powered apps and teach it a lot. And even when I get software engineers that I'm working with and I use the term test, if I have a test that doesn't pass 100% of the time, software engineers freak. And I'm like, no, sorry. If the LLM test passes 100% of the time, something's clearly wrong. So maybe we actually need, some different terminology there just to get kind of level set everyone, right?
Yeah, I love that example. That's right. When people tell me our data system is perfect, we don't have any data issues, I'm like,
Yeah.
Right. I think as people who work with data, we know data is wrong. There's no instance where that isn't the case. And similarly, like, yeah, LLMs hallucinate. There's so many instances, like that's just the reality. And I think it's not about, I think the mistake here is to say, okay, we can't trust this. We're not going to do anything.
Yeah.
And I don't think that's the case. You could argue that, no data is better than bad data. But I think when it comes to generative AI, we talked about this earlier, I think there's a lot of pressure to actually build and deliver AI products. And so, I don't think we should stop from doing that, but I do think we should recognize that when we are building these things, we are also responsible for the reliability and the quality of them. And so we must invest in making sure that we're doing what we can on our part to make sure of that.
Yeah. And so you mentioned we're still in the nascent stages, which I totally agree with, of data and AI together and observability there. I'd like your visionary take on what you'd like to see in the next 1, 2, or 5 years.
Yeah, great question. So first of all, and I'm very bullish on AI long term. I do think we will reach AGI. I'm excited for it. I do think that there's a lot of sort of significant benefits that I think our generation can have, and I hope our kids too, right? Like I do believe this can make us significantly better. And there's a variety of examples of where I think we're starting to see that. I do think the time horizon will be longer than we currently anticipate. And I think this reminds me of the internet, right? We talked about this, like it changed our lives, but it took a little bit longer than we thought.
We had a big bust as well,
Yeah,
right?
did.
Like
That's right.
I was 18 at the time, but and actually a bunch of people I went to school with decided not to go into software because of it. One guy spoke with some doctor friends and lawyer friends of his parents, and they said, no, definitely go into it. He was one of the first employees of the first Google Maps office in downtown Sydney and had a ball for 8 years here, something like that.
There you go. By the way, I think you raise an important point as I think about the future. One of the questions that I'm asking myself is, if I was, going to college now, what should I study? Like, what would you recommend studying right now? I'd hate to say don't go into AI because I do think, to your story, to your example, I think this is real and I think there will be material developments. Just it might not happen tomorrow and maybe that's actually okay, but it definitely will disrupt and improve the way that we work.
I think out of everyone we know who excels in machine learning, who studied it formally, but literally pretty much no one I know. Most of us 12 years ago took a Coursera course by someone you may know the name of, Andrew Ng, right? And then
of course, yeah,
got involved
Daphne Kohler
that way, right? Exactly,
yeah,
right?
Yeah,
That's how, a lot of this began for a lot of us.
Yeah, that's right. I mean, computer vision was a big deal back then, right?
Yeah.
Like there's a lot of that. And yeah, so I think that is a question. I don't have the answer to that. But I am excited about, go for it.
Yeah. Yeah, I have one provisional answer
Please.
with like error bars and just thinking aloud.
Yeah.
If you're trying to solve problems, try to solve a problem and build something. And what you learn along the way, start using AI, talk with people about AI, that type of stuff. And I think being a subject matter expert in something and knowing how to leverage AI, then, that's the joke. You won't, who knows whether this is true or not. I can't predict the future, although I've been working in ML and AI for way too long. You're not going to be replaced by AI. You'll be replaced by someone who does what you do, who's using AI. Right?
Exactly. I think I totally agree with you. And look, I think there's some things that are fundamentally always true, regardless. The first that is like, do something that you love. So like figure out what about this thing excites you and go for that. Like your chances of success are way higher if you actually enjoy what you're doing. And then I think the second thing is like work with great people who will force you to be better and force you to, learn whatever it is that you need. So I think those things are like truisms, at least for me. They'll always say the same. More practically, I'll just say one other thing that I'm really excited about is I think there are some early applications of LLMs and AI for data quality in particular, which I'm really excited about. Maybe I'll give a couple examples
I'd
here.
love that.
Because I think those are like really cool applications. There's sort of just from the Monte Carlo kind of space, two things that we're working on that I'm really excited about. The first is basically observability agents. So the first is a monitoring agent and the second is a troubleshooting agent. So quite simply, a monitoring agent, the problem that it seeks to solve is helping analysts who want to set up monitors for their data but don't know which monitors to set up. And so, just to describe the work of the person who would do this, they, need to know a lot about their data in order to set up monitoring. So they would need to know that the data needs to arrive every morning at 5 a.m. It needs to sync, or they need to know that the values of a particular field need to be between X and Y. But if you could actually, use semantic data and be able to profile the data, you can make suggestions for what that should be. So I'll just give you an example from baseball. You can define what the values should be for a fastball, right? Like a fastball should be, I don't know, between 80 and 120 miles per hour. I don't know. But like you can infer what that might be and make a recommendation for that. So you can actually use AI to make that process a lot better and a lot easier. That's one sort of, application on the monitoring side. I think the second part of it is on the troubleshooting side. So, I mentioned earlier when a data analyst or data person basically, has become aware of an issue, either through an alert or someone downstream told them, their work now is to uncover what went wrong. And so what they do is they basically typically will come up with sort of a list of hypotheses for what made wrong. Maybe the data source upstream stopped giving me data. Maybe I mentioned before, like maybe there's a pull request that cause, like, here's like 10 things that I want to test. And then they'll start testing them one by one and go through it. That process might take weeks or even years. This is where LLMs are so helpful. And so basically, what we've done is, we created an agent that basically spawns agents for each of these hypotheses. And the job of each agent is to basically inquire based on this hypothesis. And the magical thing here is that it basically does it recursively for every single table upstream until it finds a root cause. And so you basically have, up to 100 LLMs or agents running at the same time, looking at all these different hypotheses recursively in under 1 minute. And that is magical in my mind, because that's basically like condensing the work of like 100 analysts over like many minutes of weeks to under 1 minute. And that's the stuff that like I get really stoked about, because if we can, like, that is really, really grueling, pushing the rock uphill to like find a problem. And you can like, it's magical how it like sort of very nicely, we actually use this super LLM or like a smarter LLM, sort of more of a reasoning model, to actually summarize all of the findings and present, but here's the TLDR, like here's what we think the root cause is for this data issue. Here are the related code changes. Here are the data trends that happen at the same time. So basically like present a summary of the issue to you. And again, that can take such a long time. And when I see that, I'm really optimistic. I'm like, hell yeah, I can get behind a future where, a lot of this work that's very manual can be done with like the click of a button.
Absolutely. I think there's a very bright future there. In my experiments with such things, not only is hallucination a serious issue, so is like the forgetting that happens with LLM. So one example is I can give an LLM a data set and give me the mean, the variance, the median. Let's say I ask for 5 summary statistics. It'll come back and give me 3. Legit. It will like, one turn conversation, 0 shot. It will give me 3 of them, right? So one way to solve that, of course, is to parallelize these things, return it in structured output. There are ways to deal with this type of thing. I do wonder how much we want to have human in the loops in this process, as opposed to merely returning a report at this point. Similarly, something I've found, and a lot of people I work with have found, is LLMs can be horrible at what I just described, but they can be wonderful at uncovering insights. So if you just say to an LLM, here's a data set, tell me some interesting things about it, it will actually say things that you wouldn't have even thought to ask about, which I think is phenomenal as well. So you've got these weird, Simon Willison talks about LLMs as being weird interns. So you have these like weird analysts that, maybe won't follow all the instructions, but if you like, will come up with things that you wouldn't have even thought to ask about yourself. So I'm wondering, in this like multi-agentic approach, you've seen these types of things as well.
Yeah, great question. I'm trying to think of a specific example. I will say that there are definitely hallucinations. It is not perfect 100% of the time. So we're still iterating with our internal team and with our users. I personally, I think in the current iteration, okay, maybe I'll describe this in 3 different levels. The first level, which I think a lot of people want, but I'm not sure we're there yet, which is where you actually have like agents running these for you and fixing these for you. And I think that's like some holy grail that people are hoping for. And I don't think you want agents touching your data right now or actually making changes there. I think the second level was like agents providing you information that's like human assisted or human in loop, call it whatever you want. We're definitely there. And I think that's like very, very powerful. Maybe the stage below that is like no LLM involvement, which like, human alone. I think that's a miss if you are today, if you're not using some of that. Does that help?
It does. And I suppose there's another, I love those different levels. There is other level, I suppose, which is, as Anthropic coined the term, augmented LLMs, where it's not quite agentic, so it doesn't direct its own tool usage.
Right.
But one needs to specify when you write out your LLM workflows, how it's augmented at different points. And to your point as well, I definitely wouldn't give an agent write access at the moment, because I wouldn't give a weird intern write access as well, right? But
that's exactly right.
1, I'd give it read access, and 2, if I was in the loop, and this is, I've been doing some pretty weird vibe coding recently, but working with, Cursor in agent mode with Claude 3.6, Sonnets 3.7 is wild, right? But it has write access. I don't do it. They call it YOLO mode. I don't do that. It's in the settings, YOLO mode, right? But if it wants to make a change, it will tell me what change it wants to make, and I'll accept or reject it. So being in the loop like that, by allowing it write access, can be extremely powerful, I think.
Exactly. And I think I think we're in early days of figuring out how to do that, but I think that's where we're headed. And honestly, like that gives me confidence that it's the right path. So I think we are seeing positive feedback with those types of interactions.
Yeah, I couldn't agree more. And to your point, not using an LLM, you're losing out there.
Exactly.
Solely using LLMs and not having human in the loops when we're not there. We're not there yet, and we're in this middle stage. So I suppose then to think about enterprises that are rolling out AI powered products, and by that I mean generative AI powered products, whether it's, RAG or infinite RAG or agentic workflows or whatever, cosplay we're doing today. What are the biggest data reliability risks in your mind?
Great question. I mean, I would say I'll start by saying, again, sort of maybe the obvious. I think that the big risk for a lot of these projects is that it's actually hard to tie them back to ROI, into revenue. And I don't want to understate how important that is, because I think at the end of the day, there's going to be a come to Jesus moment when we are going to have to say, like, what have you done for me lately? And I think to a certain degree, data and AI teams today are, and by the way, I use sort of AI and generative AI interchangeably, but I think those teams are far from the business today. And I do think that the ways in which organizations have gone about building AI these days is not having a centralized strategy, but rather having a lot of small teams take things and run with them, which I think is the right approach for some experimental innovation based. I think over time that will consolidate. But I think in those instances, the expectation for the ROI is lower. It's basically like, it's not uncommon for me to speak with, Fortune 500 pharma company that will be like, yeah, we have like about 270 projects in production. We're not totally sure what's going to like add value, but it's like a portfolio based approach, right? We're just going to like, throw a bunch of stuff at the wall and see what happens. I think that's a totally valid approach for where we are in this innovation cycle. But I think that's a big risk, if that makes sense. I think particular when it comes to reliability risk, I spoke about this earlier, but I think the data can break in a million different ways. You can trace it back to data systems code model, but at the end of the day, all of those risks will hurt your brand, your reputation, your revenue, and those are real things. And maybe the one thing that we didn't talk about is the risk that it takes, or the toll that it takes on your team. So it's not uncommon for me to speak with data and AI team and hear that they spend 30 to 80% of their time on reliability fire drills. And so when you have, again, 30 to 80% of the time spending on, data and AI issues, like things going wrong, you're doing something wrong with we're doing something wrong with how we're working, right? Like the benchmark should be way, way, way lower. And, I think flipping how we're thinking about that is really, really critical. Maybe I'll stop at that. I feel like I touched on this a little bit earlier.
Yeah,
would you want to expand?
Well, I love that you mentioned, having a portfolio of different AI projects and seeing what sticks and lands, and but there is a risk associated with that. And I think we'd probably both agree, but I don't want to put words in your mouth, that this isn't just with AI. This has been with data science and ML as well for some time. And there has been a machine learning bubble in a variety of ways as well, where people have invested a huge amount. Machine learning engineers aren't, like, headcount isn't cheap. Infrastructure isn't cheap. Companies have invested a whole bunch and perhaps not seen the returns that they were promised by looking at Google and Meta and, FANG companies, right?
100%. I actually think the ML space is such an interesting case study, if you will. I think there's a lot of things that you can do better with ML. Like I'm thinking about CPG, consumer product goods that we work with that all have supply chain organizations. So think like delivery, route optimization, pricing optimization. There's a lot of things. Ads, obviously, right? For media, ads is huge for media organizations. And, in all of these instances, like ML can take you up pretty far away. I think there is a motion now. I hear a lot from organizations where they're basically retooling their ML projects with LLMs, and they are able to see some improvements on that, which is pretty nice. But I think by and large, if you look at the ML space, I don't think it delivered on the hype that it set out, when it started like 5-7 years ago. Definitely not lived up to expectations. Let me say let me hot take here. I think by definition, there's no way that generative AI delivers on its expectations, given where we're at right now. Like, I think the bubble is so massive. However, even if it's just 10% of what we think it is, that's still significant to change our lives, I think.
Yeah.
And that's maybe the difference that I would say compared to ML.
I love that you say there's no way it can deliver. I can be a troll with friends occasionally, or puckish, let's say. And I love the Beatles, but I always tell my friends who love the Beatles even more than me that the Beatles are clearly overrated. Because they are, like, anyone who's the Beatles
I love
is
the
clearly
Beatles.
overrated. I love the Beatles, but anyone who has that much mindshare is clearly overrated along some dimension. With all this AI going around, we'd think we'd have a lot more stuff automated. And so many companies just still rely on manual processes to do important things like validate critical reports. I'm just wondering why automated data reliability in the space, for example, and data reliability checking hasn't become the default yet. Why is so much still manual?
It's a great question. And I think this goes back to, I think it's just human nature to do things in a manual, shitty way. Like, it's kind of like our, default. I always think about this, like, it's sort of our default to be like slow and unfocused. Which, by the way, like at Monte Carlo, we have this sort of, I don't know if called mantra, but like something that we try to live by is like speed and focus. Like, choose very few things and do them really well in a focused way. I find that that's helpful to remind me every day because I think by default, we are not fast or focused as just human beings. And so I think in a certain sense, like it's our default to do things in a manual way. And I think it does make sense. Like, we talked about human in the loop and why you wouldn't want to give, write access, but you do want read access. So I do believe that this is, evolution and that as human beings, we're process things in an incremental kind of way. It's a lot easier for us to make incremental steps.
And I'll just add to that.
Please.
I haven't reflected on this quite, but when you said, we do things slowly and
not to hate on us, but
not, but we're reality check, right? I do think we also we need a reason to change the way we have a lot of energy, but a lot of life is energetically consuming. So we are beings of inertia in some way. So if something isn't the best way to do it, but we know how to do it, I'm not going to necessarily pick up a new tool unless I have to, right?
That's exactly right. And I think oftentimes it's very comfortable to do things the way that you've done them before. And again, I'll remind you, a hot second ago, like just 7-10 years ago, you actually could really, like, having the level of diligence on data was not acceptable at all. So like, having an issue or a mistake in your data happened all the time. I remember, at the time I was speaking with, C-level folks and, their biggest issue was they were reporting the wrong numbers to Wall Street and finding out about that like 24 hours later. Right. And like, that was sort of like the biggest thing that can happen because mostly people used, to your point, like use data to sort of count customers or count something, product users or monthly active users, and getting those numbers was hard. And so just a hot second ago, not like actually 5-7 years is not that much in the span of a lifetime. So just a hot second ago, we were using data in very limited ways. I think it's easy to forget how far along we come. I sort of like to say this, like, speaking of the Beatles, I feel like the data and AI space is a little bit like Taylor Swift. We kind of feel like we reinvent ourselves every couple of years. And actually the space moves really, really quickly when you think about this. Like, Snowflake and Databricks, which are like huge, like behemoths today, they weren't that big 5 to 7 years ago. And so I think most enterprises that I speak with, their biggest problem is still, how do we get on the cloud? And so in that world, thinking about like fully automating, your data quality or data reliability is a lot harder. I do believe we should be moving to the cloud ASAP, like yesterday. So like all these enterprises that like need to do that, they have to catch up. But it's just the path there. The reality is that the path there is longer. And to your point, it requires pretty significant change agents in the organization to say, hey, we're not going to do things the same way we've done before. And I think the reality is enterprises can't afford to not do that today. And I think it was called digital transformation a few years ago. And, that was very hot for a couple of years. And now everyone needs to use AI, but like you need someone to push that in order to make that happen.
Totally. And look, there are lots of incredible cloud tools out there, and I won't name any names, but it isn't as though like a lot of you can do amazing things with them. Isn't as though they're always easy to use as well, right?
No comment. I'm kidding.
Yeah.
No, you're totally right. I mean, look, I think it's a combination of like, cost and skill set. And I do think the rise of cloud solutions has allowed, because of the standardization and things in the access, that has made it a lot easier for companies like Monte Carlo to create standard solutions. That makes sense. Like building a company that's largely on-prem is very, I think it sort of degrades the experience for the customer, and it's a lot harder to maintain and to scale. And so, companies that are sort of cloud native have that advantage. And so I think we are a company that's making a bet on the cloud. And we've been able to do that thanks to cloud advancements. It would have been hard to do otherwise. And so, I think by and large, the advantages or the benefits outweigh the issues that it has, because it does allow, to create a much, much better customer experience. And that at the end of the day is, I think, really, really what matters. So yeah, you're right. It's not the easiest, but I don't think it's like harder than on-prem or whatever we had before.
Yeah. I was referring to the three big providers and the fact that their products seem to, I think they have different product teams. It's whatever Godwin's law, or whichever one that is, the product reflects the way the organization is structured, right? And I'll have a notebook open and literally not being able to connect it to another part of whatever that offering is. Like, it can take me 10 hours to figure that out. I'd love an agent to do that for me.
That's
actually,
right. That's a good idea. You should suggest that.
And also, some of the cloud providers introspecting into costs and charges is not always trivial, and those can blow up pretty quickly, right?
Absolutely.
I'm so excited to hear from you a bit more about what observability for LLMs and AI agents and augmented LLMs can look like. And I think my bias is, as I mentioned, I help people build a lot of LLM powered software, and they're like, hey, should I use this framework, or I want to do multi-turn conversations, or should I use this multi-agentic architecture? I'm like, firstly, what are you trying to do? And they're like, something cool. And I'm like, okay, have you looked at your traces? And they're like, what do you mean? I'm like, let's actually look at the data, perhaps even label some of the failure modes in a spreadsheet, do a pivot table to see what the biggest failure modes are, right? And they're like, but I want to use Crew AI. And I'm like, let's just step back a bit. So, and the other thing, I suppose, is to one of your points earlier, with generative AI powered applications now, observability comes a lot tougher because of all the unstructured data these systems are producing as well. So how do we even think about logging these things and observing and all the data we're creating? So I know that was a whirlwind of questions, but I hope something in there hit.
That's great. And I think that's something that's top of mind for lots of folks. I think, one sort of approach here is that AI observability and AI quality is a lot different than data observability. I actually, I don't know if this is a hot take, but I will say that I think the data and AI stack are merging. I don't think there's going to be two different stacks. I don't think there's going to be some secret super player that's going to come. I think the incumbents in data are going to be the incumbents in AI. And I think in the same way that software engineers build with various stacks, data engineers and software engineers will continue to build data products with various stacks. Like, it will not be homogenous. I don't think there's going to be one stack to rule them all or something like that. That's my hot take. I do think then when you think about observability for AI powered application, some principles hold true if you think about data and then expanding out to your data and AI estate. So I really think the backbone of the AI estate is the data platform and the data foundation. And then on top of that, you have a variety of things. You have agents, maybe you have a vector database, maybe you have prompts and context and structured and unstructured data. You have orchestration systems, you have agent systems, you have model responses. Those I view as sort of an extension of the data estate, if that makes sense. And I think in order to do observability, you're going to have to do it end to end. So in the same way that we think about end-to-end software observability, we also need to think about end-to-end data and AI observability. So you need to be able to, first of all, have visibility into that full estate. So you have to have connections into to your full stack. You have to have a single view or a couple of views of how those all connect, and lineage becomes very important here. And then I think you need to have view into where things are wrong and why. And I think you can use data and AI to do that faster. I think one common issue is that people think that's because of a lot of legacy solutions. They think that's a very manual process. It's no longer a manual process. And so if you really think about data and AI, instead of thinking about it as two separate technologies, but thinking about it as a single system with a single stack and a single view of observability, I think that's how you should really think about that. And I do think that all of these things, when I take into consideration all types of data, systems, code, or model outputs, those remain to be the four core things to observe. And you have to observe them across every single component in that stack, if you will. But those are the four ingredients that make that entire stack. There is not a single solution that does all of that today in the future. I think that's, my vision for what I think very strong observability should look like. I think that's where the world is going. And I think we're not going to be able to operate our AI systems without having that kind of visibility, if that makes sense.
That makes an absolute sense, and I appreciate those insights so much. So we're going to have to wrap up in a minute, sadly. But I am wondering, what the biggest blind spot in how organizations think about AI and AI observability and data quality today, and what's coming that they're not prepared for and should be?
Okay, I don't know if this is a super hot take, but I do think, we talked about this earlier, there is an obsession with the latest and greatest model and, GPUs and performance and how do we get there. I actually think that's a red herring. And I think the thing that folks should be focused about is whether their data is AI ready and whether their organization is AI ready. Maybe this is a hot take, but I think 90% of organizations, maybe 99% of organizations are not there. And, I said this before, I'll say it again, AI is only as good as your data. And right now we have a lot of work to do to get there.
Yeah. And I love that you mentioned before. I mean, it is obvious, as you stated, but it seems like we do need to be telling people the obvious things at the moment, is that this needs to be baked into the DNA of every company and culture. And it has to be top down, but also in hiring, bottom up, right?
Totally. And to your point, I don't think that there are people who have formally studied this stuff. And so when you're thinking about how to infuse that DNA, I think, there's that last mile of how do I actually make this applicable to my enterprise or to my organization? It's very hard to teach. It's very hard to study that. But I think that last mile is the most important and the hardest part. How do we make this technology actually applicable and useful for us?
Yeah.
That's a skill set that's very hard to find.
Yeah. And to a point you made earlier as well, as I said, when I help people build AI-powered applications, a lot of the time they're focused on micro evaluations, like this LLM call, how often does it hallucinate? And I'm like, chill, we need to figure that out. But how do we tie it to the macro level business metrics? So having a tight loop between micro level technical metrics and macro level business metrics is not only important, will become increasingly important as we all need to deliver actual value.
Yeah. And don't get me wrong, evals are very important. It's an important part of this, but we oftentimes have a tendency to not see the forest for the trees, right? So we need to ask ourselves, do we have the foundations in place? Do we understand where we're going? What's our North Star? Who's the customer that we're building for? What's the use case? What level of hallucination can we tolerate? There are a lot of questions to answer.
Absolutely. Well, thank you for such a great conversation. I could have chatted with you for hours and I hope to in the future, but really appreciate you coming on the show and all your wonderful work and insights from Monte Carlo, Barr.
This was such a wonderful conversation. Thank you for the great questions.
Thanks so much for listening to High Signal, brought to you by Delphina. If you enjoyed this episode, don't forget to sign up for our newsletter, follow us on YouTube, and share the podcast with your friends and colleagues. Like and subscribe on YouTube and give us 5 stars and a review on iTunes and Spotify. This will help us bring you more of the conversations you love. All the links are in the show notes. We'll catch you next time.